Hi, the SI meteorologist Paul Dorian here with a brief discussion on ensemble forecasting. Ensemble forecasting is a phrase that's becoming more and more widespread in the world of weather forecasting. It really started in the 1990s, but has kind of taken off over the last decade or so. And what it has to do with is giving the weather forecaster a degree of certainty with respect to a computer forecast model output for a given weather event. In another video, we talked a little bit about how computer forecast models work with respect to input data. Specifically, surface observations and upper air observations are fed into these models that then run a series of fundamental equations to describe the atmosphere and come up with predictive results for such weather parameters as temperatures, winds, and moisture. We also talked about some of the inherent problems with the input data or initialization data that's used for computer forecast models. For example, upper air reporting stations have wide gaps in between the stations in the U.S., for example. All these radiosonde sites are sometimes have a couple hundred miles in between locations for upper air reporting stations. Even surface observations are on a denser network than the upper air reporting stations, but even there are some gaps in between. Now, satellite imagery, specifically polar orbiting satellite imagery, is also used to enhance the data coverage and the initialization data that's fed into these computer forecast models, as temperatures and moisture can be inferred from the satellite imagery. But even there's still some problems with input data that's fed into the computer forecast model. So one of the ways to get around that problem, or at least to alleviate that problem, is to set off computer forecast models for a series of different initial conditions that vary only slightly, but nonetheless give the weather forecaster a degree of certainty depending on the outcome of several different computer forecast model runs with slightly tweaked initial inputs. Here's a little listing of exactly what I'm talking about here and what the goal of this is. Again, computer forecast models are initialized with the current weather conditions, surface or upper air, but ensemble forecasting has to do with running each computer model with a slightly different initial condition, perhaps a tad warmer or a tad more moist, and to see what the output would be. And if the output does not change dramatically, then that would give the forecaster a degree of certainty with respect to that particular computer model forecast. Now, I want to show an example of an ensemble forecast. In this case, is from a great weather website called Penn State eWall. All you have to do is Google that, Penn State eWall, and you'll get to this website. And they have a user-friendly graphical display of what's called the Short-Range Ensemble Forecast, SREF. And this particular type of ensemble forecast shows a series of models, different models that have slightly different initial conditions, and then you can see the output for those slightly tweaked initial conditions. And again, in this particular case, you get 21 different members, as they're called, or different panels for different models and different initial conditions. And if the output varies tremendously amongst these models, that'll give the weather forecaster some uncertainty and certainly will lose some confidence in the output for those particular computer forecast models. So let's take a look at this now from the Penn State eWall website. Well, here's the SREF, the Short Range Ensemble Forecast, and we're looking at just a series of ensemble members. In this case, we're looking at 15 members from the short range forecast just with respect to precipitation amounts. And this particular row has the ARW model with 5 different members. In other words, the initial conditions are slightly different for each of these 5 different members, and this is the forecast model output at the same time for all these 5 members. Similarly, the NMM model here has 5 different model outputs with 5 different, slightly different initial inputs. And finally, this row here has the same sort of thing, 5 different members, as they're called, with slightly different initial conditions for the RSM model. So you notice here that there's some differences for each given model depending on the initial conditions, but only slight variations in this particular weather scenario where there's a cold front moving into the mid-Atlantic region. This particular model, the top row here, the ARW, has more moisture, it looks like, and more precipitation than the second row here, the NMM model. But again, the important thing is not only look at the difference between the models, in this case the top row ARW versus the middle row NMM versus the third row here RSM, but also look at the individual models and see how initial tweaking of the conditions up front, surface and upper air for example, has an impact, or whether it has any kind of a major impact. Well, another nice feature of this particular website, the Penn State EWAL website for this ensemble forecast, is that they also output the SREF mean. In this particular case, we're looking at pressures and precipitation for this particular forecast situation. So this mean output display here, this graphical display, is for all 21 members, those top 3 rows, and then here's a fourth model here, the ADA model, that has several different members of it as well. And this particular mean gives the forecaster the ability to say, hey, if we tweak the initial conditions slightly, what will the overall mean look like for several different models with slightly tweaked initial conditions? So again, it allows the weather forecaster to develop a degree of certainty or uncertainty depending on the output. For example, in a snowstorm situation, if you look at the ensemble forecast and all 21 members are developing a major snowstorm, let's say for DC to Philadelphia, then the forecaster is going to have quite a bit of confidence that the operational version of that particular computer forecast model is going to be accurate. Now, meanwhile, if you had the opposite situation where 21 members of a particular model or several models had widely varying results, then there'd be a lot of uncertainty for that particular forecaster. So that's it for now. That's a little bit of a discussion on ensemble forecasting. I'm the SI meteorologist, Paul Dorian.